Greetings and welcome to another webinar from the Networking Storage Forum of SNIA. This one's entitled Storage Life on the Edge, Managing Data from the Edge to the Cloud and Back. Now, before we begin, I'd like to remind you of a few items. First, open your browser in full screen mode. That way you'll be able to see the small text that exists on some of our slides, as well as some of the cool animations. When we get to the end, please give us your feedback. That way we can continue to improve our presentations for you. The question always comes up, where can I get a set of these slides? On the Attachments tab, it's there ready and available now. If you could please hold your questions for the end of the presentation, we'll answer them. Feel free to go ahead and pose your questions at any point through them. We just won't answer them until we get to the end because there's a lot of material to get through. Hi, I'm Tom Friend. I'm your moderator today. Our expert panelists today include Dan Cummins, Vice President from Dell, John Kim, who many of you know from his life in marketing at NVIDIA, and Dan McIntyre from Samsung. So SNIA, the Storage Networking Industry Association, is comprised of 180 leading organizations with over 2,500 active members supporting 50,000 plus IT end users and storage professionals around the world. Within the Networking Storage Forum of SNIA, this particular group, we cover a wide variety of topics around networking and storage with details on network and storage protocols, management, and security. I won't read all of this slide to you, but the basics are, you can use this material in any presentation as long as you give SNIA credit. Also, I'm a moderator, not a lawyer. If you need one, contact one. No warranties. Please use at your own risk. Today's agenda is as follows. We'll begin talking about data and compute pressure points, aggregation near and far edge. What does all that mean? Supporting edge workloads is another great topic we get into. And then analytics and AI considerations for this data. Also understanding data lifecycle to generate these insights from the data. And then governance, security, and privacy, just in an overview. With that in mind, I turn this over to Dan Cummins, who will take it from here.
Great, thank you. And thank you all for having me today. It's very exciting. Okay, so what I'm going to talk to you today about is about some of the data drivers making edge necessary. So according to industry analysts, by 2025, more than 70% of the world's enterprise-generated data is going to be generated outside the core data center or cloud. Now, much of this data is being generated from the explosion of IoT streaming data or IoT sensors across many edge verticals. So, typically today, it's very easy to develop edge outcomes, using a cloud-first strategy or using a centralized strategy. But the challenges that we have with all of this massive data generation is that things like data intensity, the time to generate actionable insights, right, which could ultimately affect safety, security, and so this really leads us to we really need to be able to generate immediate and essential value from the data at the point of generation. So this leads us to moving away from centralized architectures to more of a distributed architecture. And as we go through the presentation, we're gonna talk about what that really means. But basically, it means how do I process more of this data at the point of generation? Okay, so here at Dell, when we take a look at the edge, we kind of have to break it apart into the edge computing locations to really understand the workloads. But there's also constraints that are driving what type of workloads, are prevalent across these edge locations. So if you take a look at the far right-hand side, you'll see something that we call the functional edge and the far edge. What's interesting about this is the functional edge you can think of as your single function edge compute location. Very fragmented. This could be a painting robot. It could be an in-vehicle, edge compute. It could be a forklift. It's kind of like that IoT edge. Also located, near this is the data that is generated from the functional edges consolidated or aggregated into a far edge location. And that could be like an IoT gateway or an industrial PC, or a ruggedized server, for example. But this compute really exists in a constrained environment, meaning it's more or less in an environmentally hazardous location that also requires somebody who's trained, an edge worker who's trained in the safety and security protocols of that environment. It's not traditionally IT focused, right? Um, the other location that we see, from our customers is, what we call a near edge location, which is close to the far edge. This is actually where you start to see traditional IT with an IT rack, in an air conditioned space serviced by IT personnel. It could be on site in the back of a store, or it could be in a local or regional data center or point of presence. But typically, it's much smaller in scale and more distributed. Then, of course, we have the core data center, which we all know, as well as cloud. So it's really, you have to kind of understand, these workloads. So in general, when we put all this together, a good use case to take a look at for processing of workloads at the edges, and I'm going to use an example from, say, the manufacturing space. So on the left-hand side, we have what's called an OT network. That stands for operational technology. And you can see this is where you have safety, security, environmental constraints, right? This is equipment that is out on the shop floor or in the warehouse, connected to that functional edge, which is streaming the data, the telemetry in. Um, and, normally the applications that provide an outcome is a distributed applications across multiple locations, across the core data center, the cloud, and the edges. So when we take a look at this, a common use case that generates a lot of the data at the edge is the computer vision use case. Now, the computer vision use case, for example, includes things like quality control, fraud detection, self-checkout. So much of the data that's generated by the cameras in this case are all coming in from that functional edge or that IoT edge. And they're coming into a IoT gateway or some point of aggregation where that data is then filtered. Um, Now, typically, because this OT environment, this far edge environment is constrained, it's constrained in the amount, the cost of the infrastructure that's out there, the refresh cycles, things like that. So typically, you'll see non-traditional IT infrastructure out there. Usually low-cost compute that's disposable, because of the service model. These things are in remote locations. But typically, the data that's generated from the functional edge is streamed through this point of aggregation, and it's a store and forward. And it's usually stored and moved to a near edge location where you have IT infrastructure that has the compute horsepower and GPUs to do the inferencing, for example. Now, most of the data generated, or most of the data that is being inferenced, will be dropped on the floor. So it's something that's temporal in nature. Anything that falls out of inferencing that requires a data scientist to look at or to retrain the model is then further moved further upstream and operated on in the background in a batch processing model. So that's where that data would be moved to the core data center or the cloud, where a data scientist will look at it, retrain the model, update the model, and push that model back down to the edge. So this is a typical workload that we see today. Now, there's a couple of things that are going on here related to these workloads. There are some customers that we've talked to that have taken a cloud first approach, that centralized approach, where they're doing their inferencing in the cloud as well. As we know that, on average, that could be, something like 300 millisecond response time. And the bandwidth that's required and the transport fees that are required to send that data say from a vehicle all the way up to the cloud to have it inference in the cloud, right, and then take action based on that inferencing is can be lengthy. Um, in order to reduce costs for transporting that data, we see some of those customers actually transcode their video streams into a lower bit rate to reduce transport fees, right? But that also impacts the fidelity for inferencing. So kind of not a really good solution. So what we typically see is kind of a hybrid solution where they start to leverage in a distributed way these edge locations. Okay, so in general, what we see is most of the data that's generated at this far edge is usually unstructured data, uh, and most of the bandwidth that's generated or that's needed, for this data is for video, and video doesn't compress very well. And then the other data is, typically telemetry data, which is very small, compressed as well, and things like that. But it's temporarily buffered and stored at the far edge and then moved to a location that can further act on that data. It's a streaming architecture. So these two locations do stream. When you get into the near edge, that's where you start to see a mix of workloads, both IT workloads and edge workloads. But the edge workloads, because most of the bandwidth that is needed, it doesn't compress well, so you don't need things like data reduction for your edge workloads, but you do need data reduction for more of your IT workloads that are actually running your business. So this is typically what we see. So in general, just to summarize, for folks is if we take a look at the far edge, most of the workloads that are coming in from the far edge is unstructured data, usually video and telemetry, and it's a streaming architecture, meaning that the data is coming in. It's being stored and then forwarded to a near edge location, and then a near edge location, does have the ability to basically inference that data. And you'll see a mix of both streaming and batch workloads in these locations because it's a mix of both IT and edge workloads. So data reduction, like I said before, doesn't work too well for much of the edge workloads, but it does work for the IT workloads. And then, of course, all of your batch processing, structured and unstructured workloads, that exist in the cloud are usually out of band or background operations. So in summary, that's the kind of workloads that we see across these locations, and they're all driven by the need to solve for vertical use cases, and those vertical use cases are made up of distributed applications that are distributed across the edge, the core, and the cloud. So, John, I'll hand it over to you.
Dan, thank you very much. That's an excellent introduction. Actually, let me build on what you said and talk specifically about one application that has been moving to the edge to a certain extent, and that's analytics and artificial intelligence, or AI. So first, I think it's useful to talk about the traditional method of doing this analytics and AI is you collect all the data, which a lot of it comes from the edge or the data center, other data centers. You can buy external data, it could be from the cloud, but you take all this data, you move it to your central data center, usually your on-premises data center, but it could also be in the cloud, and then you process the data there. You do the training there, and then you build models, and then for AI, you do inference, which is actually interpreting the new data coming in using those models that you built. So all your compute power, your storage, your analytics, your models, and then what we call inferencing, which is again the interpretation of any new data coming in and the decision making using AI, is all done in the same place or the same places. So you have lots of compute power, lots of network bandwidth, lots of storage, and you have very low latency within that data center. It's very easy and fast to move data from different servers to other servers or to storage, to use CPUs and GPUs or other different accelerators, and you can pretty much operate as you want. You're only limited by the type of hardware you can deploy and the software models that you run on it. So it's fairly straightforward. And in terms of security, security is also straightforward. Not because security is ever easy, but because you generally have everything in a data center. So you set up a perimeter firewall, and mostly you try to stop or detect threats at that firewall. And it's fairly simple because you don't have to necessarily catch or detect threats out there at the edge of the network or outside the data center. So again, this is a basic model for traditional AI analytics. Edge is just for collecting and generating data, but all the use of the data and the processing of the data is in the main data center. Now, as Dan said, there's more data being generated at the edge, and now there are also more people and devices and applications or appliances that want to use that data out there away from the data center at the edge, either at the functional edge, the far edge, the near edge. The point is that now much of this data is not only generated somewhere else, but they want to use it. And the traditional method of sending all the data back to the core data center now introduces too much latency in many cases, because you have to send the data back and you either don't have enough bandwidth or it takes too long. You have too much latency to get the data back, process it, make the decision, and send the decision or the results or the analysis back out to the edge, where you now have users or machines that can use that data and want it out there. So this is a problem with when you have more use of the data, more generation of the data, and the decisions out at the edge, but you're trying to do all the analysis and processing in the core data center. Also, as you do this, it does introduce more security risks, and Bill will talk more about that later. But because you now have more potential attack points, more places, not necessarily more vulnerable, but you have more places that someone could attack, and a lot of that is outside the traditional corporate firewall. So you have to find other ways that maybe to protect that data, or other ways to detect potential breaches or compromises when it's outside the data center. So again, this is the problem that we're trying to deal with as we get outside of the traditional model for AI and analytics. So how can we deal with this? So I should step back and talk a little bit more about how this traditional model works for AI. So normally, traditional AI or machine learning works in this kind of continuous cycle. So you get data, so you collect the data, generate the data, you clean it and prepare it. You then do training, and this is the part that requires usually the greatest amount of compute power, the most storage, the fastest processors, the most electricity. You do that training and you build these models. These models could be built with usually they're built with neural networks or deep neural networks and different types of machine learning. So build these models, then you validate them, you bring in some more data and test the models, and when you're happy with it, you deploy the models. Again, traditionally to a central data center, but increasingly now you can deploy those to the edge. And then you actually run what we call inference. And inference is basically like saying, okay, I've been trained to recognize what a cat looks like, give me a bunch of images, and I'll tell you whether or not it's a cat. Or I've been trained to recognize someone's voice orders when they want to order something from Alexa on Amazon, or they want to tell Siri to do something. So I can be able to interpret what people are saying, or analyze video, or maybe analyze someone's X-rays and figure out whether or not there's cancer or tumor in that X-ray. That's known as inference. I take these models that have been built and trained, and I use those, and very quickly in real time, or very near real time, I'm actually making decisions or performing analysis on the data with these models. And then we collect some data from this, we analyze the accuracy of this, we collect new data, and we feed that in, and we start the cycle again. So we then go do training to make either new models or to improve the existing models, and then we validate them and deploy the new models, and then do inference. So a key characteristic here is that the training part, as Dan said, the training and the validation and the cleaning of the data, that is not usually done in real time. That can be done asynchronously. It can be done in batches. You want to do it quickly, but if it takes 8 hours instead of 2 hours, that's usually okay. It's not something where a decision has to be made about a self-driving car, or about what kind of ad to serve someone on their phone, or about what kind of whether or not the police have to be called because there's something suspicious on a video. Those decisions don't have to be made immediately or in real time when you're doing the training and the validation and the data preparation. But once you actually deploy the models, the inference part has to be done very quickly, and that has very low tolerance for latency. And those are the cases where you usually can't send the data back. You have to make that decision somewhere at the edge, the functional edge, the far edge, or the near edge, as Dan mentioned. So what we can do is we try to move some of these decisions or some of this processing out there towards the edge. And what I did is I should have labeled it, but I've coded the pink parts or the pink squares are the ones that are most easily are usually moved to the edge first because they're easier to distribute and move out there onto the tablets, the phones, or the cellular base stations, the IT closets in the retail store. Those functional edge and far edge locations that Dan talked about. And then the purple areas are ones which could happen both either in the main data center or out there at the edge, perhaps at the near edge. The purple is less likely to happen at the functional edge or far edge, but it could, again, that's something that could be done at the near edge or in the main data center. And the blue parts are the parts that traditionally stay in the core data center or in the cloud. People certainly do a lot of their AI training and validation and model development in the cloud if they don't want to run it in their own data center. So that's the current status of how things are in terms of how you can distribute it. You try to keep the training and the model validation and model design in the main data center, but you push the inference, the data collection, and sometimes the deployment and perhaps some of the data preparation. So for example, you could do data filtering or compression or sorting out at the edge or even with computational storage before you send it to the core data center. And you tend to push that out there to some part of the edge. And there are other things you can do at the edge, which we won't talk about, but we might cover in a future webcast, which would include, for example, using accelerators out there at the edge or deploying things like computational storage. But those topics are probably for another webinar on another day. Okay, I will go ahead and wrap up my section, and we'll now cover, David McIntyre is going to cover governance, security, and privacy and how it relates to the edge. David?
Thanks, John. Yes, so I'm going to talk about this topic, and I'm going to talk about just a sneak peek on computational storage. So great segue. So as we go into governance, security, and privacy, what are we talking about here? Well, we're talking about, I would say, the real world deployment concerns that our end customers, that our cloud service providers have around all the great infrastructure and solutions or device solutions that we're building as vendors and also just as a collective within SNIA. So this let's get a level set here. So the current threat landscape it's alarming. As a fellow layman on these sorts of topics, if it's not right in front of me, I probably don't think about it much. However, we do have experts within SNIA that think about this full-time plus. And here are many, just a sample actually, of some of the threats that we need to at least realize. We don't have to be the experts on them, but there are many different considerations here from, denial of service, cryptojacking, mobile malware. They sound fun to say, but when it comes to addressing your data security and privacy concerns, they're not so fun. Broken access control, broken authentication, the list goes on and on. IoT weaponization. So as we become smarter from a application and infrastructure deployment, the two go hand in hand from cloud to edge, like Dan was talking about. Now we're dealing with additional security points of intrusion. So, where does all this come from? Well, it comes from threat actors. So security is a people problem. It's not just, okay, there's a piece of malware. There was someone behind planting that malware in our infrastructure. So anywhere from cyber terrorists, government-sponsored bad actors, organized crime, cyber criminals, hacktivists, insiders, script kiddies, internal user errors. The list continues to grow. These motivations can be political, they can be military based, they can be financially based, they can be revenge based. So all these threats, they're not going away anytime soon. And so I think security, I would suggest, was perhaps, at least for the layman level, more of a second thought to consider. We need to bring it more into our foresight as we build out these novel compute, network, and storage infrastructures to support applications from cloud to edge. And in fact, it's not just security, it's also privacy. With all the patient data that has to be properly managed, and now we're looking how to bring compute power to the edge, to the doctor's office, and then maybe sending up the results of that patient CT study back up to the cloud for further analysis. The data is moving, and privacy needs to be addressed. Sometimes privacy concerns can only be addressed by keeping that data local to the edge, where it's not being redistributed back to, say, a cloud service provider. So privacy is now, if you see in the yellow circle, it's almost equal size to current security issues and information security, cybersecurity. And personal data protection, of course, is the intersect point across security and privacy. We want to keep our data private and secure. And underneath, this is what I was getting at on the prior two slides, the ethics, the moral principles to govern the person's behavior and conducting of an activity that best supports privacy and security concerns, so we can put up that defense in a proactive manner instead of reacting to those bad actors. So cloud service providers, which do build out cloud to edge ecosystems today, here's some of the concerns that they've listed to us as a vendor and infrastructure community. And this list is not inclusive, but it's a good example of some of the key points we need to address. So data in flight, moving the data back and forth between cloud to edge, or from on-prem to cloud for a hybrid cloud deployment, or even multi-cloud, provisioning data where available resources are available or application-specific processing is available from CSP to CSP. Processing requirements in data handling, both to preset that data, prepare it for processing. That opens up the data to further threat exposures. The buffering and caching, where the data is stored temporarily before it's computed upon, and then the data at rest. What are the policies around that? These are concerns and policies that the CSPs have today. Also, containerization. When and how is data privately secured within a specific application container? And how are the compute resources provisioned across a series of containers? Virtualization of compute storage resources, multi-tenancy. I don't want to know your patient records and you don't want to know mine, yet they need to both be computed upon. And edge deployments with computational storage processing, where you actually bring the compute to where the data is created and where it resides. So computational storage and security is one example where, for one, the value is clear. Instead of having to move the data across the ether to a cloud service provider, for applications that require real-time processing with minimal latency, bringing a processor element within a solid-state drive or an array of solid-state drives is a good thing, and it especially with the explosion of edge data, where it will become dominant within just a few years, that computational storage and a processing technology provides a strong value. However, by doing so, we're complicating the system a little bit, and now we need to address the security concerns in computing the data locally. So data at rest, process data, and then also sending results or having some collaboration with the traditional host, either on-prem or in the cloud, in data transmission. That also opens up security concerns too. So in summary, cloud service provider data security policies, they need to be supported. And the best way to do that is to become educated and learn about them. SNIA provides significant education on that point across our SIGs. And then hybrid cloud deployments need to also be concerned with security and address them. SNIA is defining a computational storage architecture specification with security in mind. So the group has been, the special interest group has been on comp storage. Actually, the technical working group has been working on the architecture specification for a long time, and it's coming to fruition where it can now bring in that security element. So we encourage everyone on this call to join the SNIA computational storage twig, join SNIA even more so, and support a secure computational storage solutions ecosystem and address these security and privacy concerns proactively. Thank you.
Well, thank you, David, Dan, and John. Appreciate all your information on this. So, 3 important things to know from all of this. Location, 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 right? Everything a realtor will tell you. You know, it's all, whether it's edge, near edge, far edge, close edge, yes. You know, there's latency and data integration points along the way. Processing often has data reduction points as a part of that. And security, as you've seen, have an awful lot of overlapping and competing, sometimes, priorities. So we open up now for any questions that you might have. And the first one that came in, could an application be deployed simultaneously at near edge, far edge, and functional edge? Whoever wishes to take that.
I can take that one. This is Dan. So many of the applications or the outcomes that customers need, depending on the vertical market, whether that's manufacturing, retail, oil and gas, what have you, require processing that's distributed at each of these locations. So absolutely, if we go back to that computer vision use case, you can see that part of the application or the outcome includes an IoT stack, right, that is deployed at the far edge that's ingesting the data, from the cameras, as well as an AI ML streaming framework that in runtime, that is deployed, to process the model at the near edge, and then also, applications to do the retraining up in the cloud. So yes, absolutely, many of the outcomes actually are distributed applications that are deployed simultaneously across the edge, the core, and the cloud.
Thank you. So can the cloud ever be considered to be at the edge?
I could take that one again too. So the edge has a different meaning to many people, right? So a cloud is an edge, right? One of the trends that we're seeing also is when I put that taxonomy out there, we had what's called the functional edge, right? Or some people like to refer that as the IoT edge. And then you have the far edge, and then we have something we define as a near edge, a core data center in a cloud, right? But that cloud is an edge. Okay. Now, what we're seeing also in the future, we didn't talk about this, is that the onset of private wireless or 5G, for example, has the ability to be able to connect that far edge or that IoT edge directly to a cloud or directly to a data center, right? But each of those, eliminating the edge computing locations in between, right? So you can think of like an always-on world, and with the speed and the bandwidth that you would get with 5G as it becomes ubiquitous, allows you to connect processing in a cloud or a core data center directly to the IoT edge, which is pretty compelling. But yeah, cloud is an edge.
Okay. Well, here's other differentiation questions on this as well. Example, if I'm using a tablet inside a connected car, where's the edge? Is it the tablet, the car, A nearby cellular base station, where does this fit?
I can take that. I think that's actually more a question for Dan, but I'd say all of those could be different parts of the edge. So the tablet could be the functional edge, the car, or the car may also be the functional edge, because they both, as Dan said, have a sort of constricted or restricted domain in terms of its, the hardware is fairly fixed. You can update the software, and you use it, fairly dedicated functional processes. Don't really have any IT stuff going on. And then the cellular base station is probably the far edge. Dan, correct me if I'm wrong. And you could have a telco office like a Verizon or AT&T or T-Mobile processing center or small data center that could be the near edge data center. Or this information could then flow into the cloud, and the cloud could be that near edge data center before some of the data ultimately goes back to a core data center that's run by AT&T or Tesla or Google, or if you're using one of the Google apps and so forth. Dan, would you say is that an accurate description?
Yeah, that's accurate. I just kind of want to summarize, for the audience that, people say, where is the edge? Well, there is no one edge, right? What we're really talking about is, edge compute, or where does processing of data take place? And it takes place everywhere. And the applications or the outcomes that you need for that processing, if you're in manufacturing, say, for example, you need overall equipment effectiveness. You're in retail, you need, fraud detection, right? Um, where to produce that outcome, you're going to need to be able to operate, in multiple locations. And so really we define edge really as the point where data is being acted on by edge compute.
Okay, thank you.
Mhm.
In this, back to our goal of storage and that topic, how does the edge storage needs differ from cloud or data center storage needs?
Yeah, so I touched a little bit on this in my talk, right? So what I was trying to convey is that depending on the location, much of the data that's generated from, say, the IoT edge is mostly streaming data, and they got to get it to a point where they can process the data. And these streaming architectures are prevalent because as you're transporting data between locations to process the data, you could have a intermittent connectivity or a low bandwidth situation. So typically you see either a streaming data architecture or you see some sort of pub sub architecture that can handle that disconnect and then reestablish and continue, right? So but the data, most of the data that's coming in at the far edge is usually, because of the streaming, it's a store and forward, and then most of it's unstructured, right? When you start to get into upstream where you need to do more with the data, like that near edge, I had explained that you have kind of a mix of both these edge workloads, right, which is working on this unstructured data, as well as a mix of structured data for your business applications. So you have a mix of edge and IT workloads, right? And all of those are in that data processing pipeline that is needed to provide a near real-time response, right? It's not really out of band data, it's in band data. And then usually with a core data center or a cloud is where you're usually going to be operating on data that is out of band, that requires deep storage. So the data center will still continue to have, deep storage, as well as the cloud, right, where you need to expand and you need longer term storage, for analytics or for training models and things like that. So typically, and the further you go up the edge, locations all the way up to the core, the more storage that you're going to need.
Another part of that, to complement what Dan is saying, is that one needs to be concerned from an application standpoint on the balancing of compute and storage resources or memory resources as well. So latency, inherent delays, especially as performance requirements increase with applications, require localized compute and storage resources at the point of creation of the data. And so the heavy lift of processing will still be done at the cloud, where you can balance out racks and racks of compute resources along with arrays of and racks of solid state drives. However, as we expand out to the edge, having point compute and storage resources that are tailored for specific applications, perhaps as I call them edge aggregation points. So you're collecting all that IoT data and you want to provide some level of real-time processing and analytics and decision making out in the field. Having those aggregation points allow you to do so. The other part of this is how to optimize the performance uh, against that data through caching, through providing persistent memory layer and or higher performance storage flash memory. So that's actually worth another discussion on a separate time. But you can start getting deeply on how do you optimize compute and storage resources and memory resources at the edge.
Yeah, I have a comment about that. I just want to build on that one point. So one thing that I think, is non-obvious to folks that trying to build out edge solutions for their customers is that customers care very much about cost, right?
Mhm.
So if you take a look at the amount of compute that's being, with the growth of compute at the edge, there's in aggregate more compute at the edge than there is in a core data center or cloud. And if you want to reduce transport fees, or if you want to reduce infrastructure sprawl, you really want to be able to act on that data near the point of generation. So I think John talked, about how you distribute, the edge processing for AI and ML out to the edge, right? Doing so helps you filter the data, so you don't have to move all the data to a cloud or a core data center, therefore reducing your infrastructure sprawl and also reducing your cost for transport, right? And you get the added benefit of a more of a real-time response. So this is why you see new technologies that are coming out that promote acting on data near the point of generation. So if you take a look at like AWS Lambda functions, for example, right? Or even some of the data management applications that are basically tagging the data as it comes in at the edge, and they're caching it at the edge. But then they're using a centralized repository or distributed ledger where somebody can query that ledger and then distribute that query out to where the data exists, right? So, yeah.
So with that topic in mind, does AI training ever happen at any of the edge points? Or is that just reserved for cloud?
The traditional answer would be that no, AI training only happens either in the core data center or in a cloud data center. And at the edge, you only have inference. However, I don't think that's completely true. That's generally true because the training requires the most compute power, the most CPUs or GPUs, the most storage and networking bandwidth. But I think increasingly there is more and more AI training that can happen or is happening out there, especially at the near edge or the far edge. And actually I should look at, like, if you're training your phone to recognize your fingerprint or your face, I'm not sure if all of that has to go back to, to the someone's data center in order for the training models to be done. I mean, everyone knows that the actual interpretation, once you trained it, the interpretation is done on the phone, completely on the phone. Many of these phones have like a little GPU built into their chipset. And they can recognize your fingerprint or your face, even if they don't have any connectivity going at all, like no cell signal. But I would say traditionally, yeah, most or all the training traditionally was in the data center, but a little bit of it has moved out to the near edge and the far edge.
Yeah, the only thing I would add on top of that is some customers are disconnected from public cloud, right? So especially
Some government
government
customers
site,
are.
right? And even some of our retailers, they are disconnected, from public cloud, and they have their own local data centers and they do a form of federated learning, in their edges.
In, in, as John began his talk on AI, he led me to believe, at least me, was led to believe that there are other applications, but we're just talking about AI here. What are some of these other applications besides artificial intelligence that are used in this environment?
Well, the big one would be streaming analytics, right? That's non-video, right? Right. To preserve safety or to preserve production, right? Or to take action, right? So you want to take action, right there where the data is being generated. So, I think mostly in manufacturing, we see this quite a bit, right? Where a manufacturing system, is taking telemetry in from a set of sensors, running analytics on it, and then modifying their action based on those analytics, right? Now that type of data is not, when I was talking about with respect to storage, right? That's very small, unstructured amounts of data that's highly compressible, right? And doesn't require a lot of storage processing. So, but yeah, real-time analytics.
Yeah, AI can encompass video stream and camera captures, right, for security purposes. That's an additional application, for smart cities, for any mass deployment of video for security. Another one which is interesting is genomic sequencing, where instead of sending the batch data up to the cloud for processing, it can actually be done localized to the doctor's office. So that's an emerging trend. We're seeing tremendous amount of interest, especially in these days, for analyzing in near real time patient data. And as Dan was alluding to too, keeping that data private and localized, where decision making can be made to benefit that patient versus sending that data across the network.
Yeah, I would say there are a lot of apps. So the most famous apps that we talked about are probably maybe AI or use AI, but there are a lot of other apps that run at the edge. A lot of them are for accessing information, sharing information, utilizing information for people. It could be as simple as navigation, which may include some AI elements, but navigation by itself does not necessarily use AI, or the basic navigation. Apps for shopping, apps for entering information, ordering food. These are all things that can run partly at the edge, or doing diagnostics, automotive diagnostics, factory diagnostics, robot diagnostics. Those are things which may or may not use AI. But I think we might have another webcast coming up that will dive more into edge use cases, so we could cover it more there.
That's right. Anyway, along the same topic of relocating some of these points of compute and storage, this question came in. We're seeing a lot of movement towards repatriation of apps from cloud to edge data centers, or even far edge compute locations. Do you think part of that repatriation is being driven by not getting the storage locations right? And are we perhaps aiming at the wrong problem by repatriating the app to an edge?
Well, the fundamental reason people are repatriating their edge applications, to the edge, is to get that processing near the point of data generation, right? To improve their overall response, right? Now, the second half of that is the way that applications are developed 10 years ago is completely different than the way applications are developed today, right? You have a cloud native microservices container based application environment, with rich APIs and some sort of DevOps pipeline for delivery, right? continuous integration. So the rise of containers and virtualization, and cloud native application architectures are making it easier to repatriate as well, right? So I think it's both of those things.
Mm-hmm. Do you ever see a Capex versus Opex become part of that decision making as well?
Absolutely, 110%, right? So, and that's the point that I was trying to make earlier, right? So, there's two things I kept saying throughout this webcast is that don't overlook the real, so generating real time responses, right? For your outcomes is obviously important, but customers are running businesses, right? They're looking for ways to reduce costs, right? So, if you're pushing your processing out to your edge, you're doing a number of things. You're actually reducing capex because you're now filtering, the data or doing all the local processing, and making decisions locally and taking actions locally, and reducing the infrastructure for shipping all that data up to some centralized location. That reduces your capital expenditures because it's reducing your infrastructure sprawl, right? In terms of OpEx, on making it simple, that's a more complicated, response, but reducing operational expenses, comes in many forms, at the edge. One of them I talked about is, could be through how do you manage your applications through the edge, right? Containers, the leverage of containers in Kubernetes, for example. We see the hyperscalers, like, Amazon, Azure, and Google, AKS, EKS, and GKE, right? With these managed Kubernetes services, and multi-cluster management, they can repatriate those container applications and move them using the same common tool sets, to the edge. So that things like that help reduce OpEx.
I think a lot of the movement to the cloud and then the subsequent repatriation has to do with balancing of that OpEx and CapEx. I think a lot of people started out looking at, hey, look at the CapEx and move to the cloud. There's no CapEx, it's all OpEx. And so initially it looks much cheaper. It is much cheaper initially if you're first year to move things to the cloud, because you're saying, I don't have to buy these servers. I just pay monthly for what I'm using. But then after you either build up enough data or you have enough traffic or enough compute power, enough data ingress and egress, then the monthly charges add up, and they grow as you grow the amount of data or compute. And then suddenly people look at it and say, wow, if I could repatriate this data and build a somewhat efficient infrastructure, I could look at the total cost of CapEx and OpEx combined would be lower if I repatriate it back to on-premises. And also there are some security or privacy concerns, as Dan mentioned. As Bruce mentioned. As David McIntyre mentioned. He's calling out everyone's name today. But and then because you can say, well, in the cloud, maybe I can't control which country it's in or which data center. I can't prove that who has access or who doesn't have access. So that's another reason to possibly repatriate it, besides the OpEx and CapEx.
Yeah, so I think this is something that's often overlooked. I tried to give the story earlier where we were talking to a customer, that had self-driving vehicles, that took they took a cloud-first strategy where they were doing all of their inferencing. So they're collecting all the sensor information from the vehicle, including the video, and shipping that to the cloud, doing the inferencing in the cloud, right? And then doing their processing and eventing, from the cloud back down to the edge. So we said to them, well, that's going to cost you a lot of money, and they said yes, and it costs a lot of bandwidth for us to send all this video upstream too. So what we're having to do is we're having to transcode our video to a lower frame rate so that we can save on transport fees. And so we had convinced him, hey, you should probably take a hybrid approach. You can still do your training and everything up in the cloud, but why don't you move your inferencing on board with some GPUs, and you could filter the data. That way you don't have to retranscode the data so that you can maintain the fidelity of your video images, because you're only going to be sending about 30% of that upstream. And if you're going to send it upstream, since you're over a cellular network, why don't you send that to some co-location provider or some local data centers where you have more points of presences, right, for these vehicles. So, you know, that's the kind of conversation that we get into with our customers, right? Is really helping them design, you know, their solutions for their edge, but really taking a look at how can they can improve their business outcomes while also reducing capex and opex.
And as you're going through all these decisions about expenditures, uh, where does the thought process come in about security? Uh, in terms of is the edge inherently less secure than the data center, or
Well, it's
how
pretty,
does that fall into play?
yeah, it's pretty simple. So if you take a look at the compute, you know, outside the data center, you're not protected by the walls of an IT data center. So inherently, it's less secure, right? I think I read an article where, you know, 30% of all security breaches, you know, out at the far edge are through some external port, right? Um, so this is infrastructure that could be moved to a room. It could be spoofed, right? It could be tampered with, right? So you really need to, when you're deploying edge compute outside the walls of an IT data center out there in the wild, you know, you need to pay attention to zero trust architectures, you know, around how do I provide my hardware attestation as well as software attestation, right? You know, the networking as well. Can I provide cryptographic network isolation, you know, protected transports, everything else? So it is definitely a top concern, you know, for our customers. You know, for Dell, security is the number one concern.
Okay, well, with that, we're approaching the top of the hour. So a little reminder for you all, we alluded to this earlier, we have another in the series, the edge storage use cases. And that one has, you know, we've now got that on our schedule. So you'll be able to go to this link and get yourself registered for that one. Please keep that in mind. Look, you know, add that to your schedule. And you know, before we go, if you could please rate this webcast, give us your feedback, and this webcast, as well as the slides, will be available in the SNIA Educational Library, and we will have all the questions and answers from this webcast in our in the SNIA NSF blog within hopefully a few days. We'll see how quickly we can all get to this, given we do have day jobs. Also, please follow us on Twitter, and thank you so much for your time, everyone.
Thank you.
Thank you.